Hello, my name is Marco Sernacibi. I'm product manager of data science and big data at Oracle. And today we're going to talk about machine learning models and deployment. So the idea is you have a model now, what do you do with that model, right? So we're going to learn how to deploy those different models in solutions that you can actually use. That's our safe harbor statement. So this is the outline, right? We're going to see what is a machine learning model. Then I'm going to show you guys a few demos. We have demos for deploying models using SQL, building models in Python and deploying SQL, building models in native Python and then deploying them using Oracle Machine Learning, and then learning on the new OML AutoML UI function to deploy models to our Oracle Machine Learning services via REST, and also deploy models and third-party models in Onyx formats. At the end, we're going to talk a little bit about the experiences and best practices with deploying machine learning models and how to get a model. And then at the end of everything, we're going to get a summary of what we saw in model deployment. So what is a machine learning model? A machine learning model is really the end of a process. So you have a machine learning process where the deployment of that model, right, is the last part. And what is a machine learning model? Well, it normally is a lot of things. So it can be as simple as things like I want to classify a cell as benign or malignant tumors, right? Or a fraud or non-fraud, or I want to check the probability of a person clicking on an ad. I want to understand, how long before a machine fails. I want to see and compute credit scoring, right? So all of these things are, at the end of the day, models. But what are actually these models? These models are actually a mathematical function, right? So the deployment of a model is really a translation of that into something that can be used in a production system. So you take that mathematical formulation of that and then build it into something that can actually be deployed. A place to store that model is critical, and also a place to interface that model. A model that is great with no interface to the world doesn't work, right? It cannot help anyone. So invariably, the result of the machine learning model process is really this model, which is, again, a mathematical representation. It can be a very simple function, but it can be very complex. But doesn't matter what kind of complexity it has, you want to make sure that you can deploy it. So very simply put, the Oracle Machine Learning base, the Oracle Machine Learning interface provides you with the ability to deploy those OML models, right? So for example, for using something as simple as SQL, on the left-hand side, then, we see that we can build a model using PL SQL, right? I am building a machine learning model called pred affinity underscore DT for decision tree. So I'm building a decision tree machine learning model, and I am basing that input in that select statement that you see in SQL, select star for mining underscore data underscore build. And then that algorithm, then that model actually gets stored immediately inside the Oracle database. On the right, I have now the deployment of that model in SQL. So in SQL, I can dynamically score data that is coming in using that model. So now on a select statement in SQL, I can use the prediction underscore probability. And then I can call that same model by the name. And then I can say, I want to use all of the input data from my new table called mining underscore data underscore apply. And I want to check what customer has more than 50% probability, right, of accepting that offer. So that's a very simple example, and it's using plain SQL. Another option is to deploy and build the models in Python, right, using Oracle Machine Learning for Python, but then scoring them via SQL. So what happens then is on the left-hand side, I am now building a model using the same input data set, mining underscore data underscore build. And I'm going to now, instead of building a decision tree, I can build a different type of model. So I'm building a random forest model, right? So I'm calling that command oml.rf, which actually is building the random forest model object for me. And then I finish that with a fit. When I do the model fit in Python, right? This is pure Python. I'm running that pure Python using the OML module. At the end, I give it a model name. When I do that, that model name gets stored in the Oracle database. So on the right-hand side now, you see the SQL, right? So I'm again using the same exact SQL code I used before. I want to have the prediction probability. The only difference is this time I'm using the pred underscore affinity underscore RF. So instead of using the decision tree model, I decided to use these random forest model. And they could have been built both, either all on Python, all on SQL. It doesn't matter, right? It's the same thing for us. So now let's move things to a little more interesting. So now what I'm going to do is I'm going to actually create a native Python model, and I'm going to deploy that for scoring via REST using what we call the Oracle Machine Learning for Python embedded Python execution. So that for that, I'm going to do a quick demo for you guys. So the first thing is we're going to get a notebook, right? And in our Oracle Machine Learning notebooks, you can build a model using Python. So we're going to actually just use scikit-learn. I'm running a random forest classifier from scikit-learn, and I'm building that model. And that's the result of that model. The model is just running, just a plain Python model. But now is the secret sauce. I'm storing that model in the special Oracle Machine Learning data store. So that model itself, even though it's a plain Python model, open source one, I'm storing it there in that data store. And I'm going to build a scoring code for that. So in the scoring code, I'm going to use the Oracle Machine Learning data store load to load that model from the data store. And I'm going to use the predict to run the standard Python predict. That's open source. I see the result of my prediction, and I see the species and the predicted species, for example, for that iris data set, right? Now that I know that my scoring code is working, I create a function. I basically create that function or that script, and I'm going to use another special component of Oracle Machine Learning, which is our script repository. So I'm going to take that script that I just wrote, and I'm going to save it to the special script repository, where I now can actually use that component from anywhere, including here, right, directly from Oracle Machine Learning for Python. I can do an OML script load and just load that script and execute it, right? So just passing to that script the input data set that I want to use. So now I can test those scripts via REST APIs. You can check out the curl commands, right? So we have curl commands for those things. And what I'm going to do is I'm actually going to use Postman. So in Postman, as an example, right, of REST, first thing I have to get is a token. So I get the authorization token using my user and password in the database. And the second command that I'm going to do is I'm going to access that predicted underscore RF underscore species script. That endpoint in REST is there. And now my input is just select star from a table. And you get back the result in JSON format. So JSON format, and I can probably, look at it better with a table formatted as well at the output in the case of Postman. But that's basically it. So you just score that out. So now that we've seen that, we had to do a lot of coding, right? We had to create a lot of coding in SQL, in PL SQL, in Python. But now Oracle also has the OML AutoML UI to deploy models. So you can deploy those models and it will create the notebook for you. So let's take a look at that. So basically we're here, and now if you go to our new AutoML interface, we can check any of the experiments that were previously run. I can go into one experiment and I can pick one of the models, right? So in this case, I'm picking the best model that it was defined by that process. I can create a notebook. And I'll give it a notebook name. And I'll say, okay, so the notebook is built for me. So I'll go now to my notebooks, and I'll see that that model is there, right? That notebook is there. I open that notebook, and the process for building the model and scoring it, it's already there. So all of that is, I executed it already now. So everything there is written in Python for you. So you have the code for a quick look at the original data set and the data used for the experiments and all that process. You can then look into uh, the different components, creating the table, creating the train data, right, to that for that model. Then you look at the build, and in the build of the random forest is going to tell you what were the settings that the AutoML process found that were the best for this model, right? So all of these settings, the number of trees, and all of these settings are there. And now you can see the model built. So when the model is built, you can check the model out and see all the details and all of the different components you see there. You had 20 trees running for that. You used a tree impurity Gini. So there's a lot of different settings that it shows you there. And then scrolling down, you're going to see the output, right? The prediction. So I can just execute that and see the prediction coming back to me from the model that I created using AutoML UI inside the Oracle Machine Learning. And I did not have to code anything here, but I can take advantage of all of that and work on that, right? And I can finally see the accuracy of the model using something like a scikit-learn if I want to. So it is a very easy to use interface, and I did not have to code a lot, right? I did not have to touch the code. Now, AutoML UI also allows you to deploy the models to OML services. And the OML services, you then can score that using a REST. So let's take a look at how that works. So we go back to our AutoML UI and back to the same experiment we had before. So the insurance purchase experiment. When we open that and we again go to one of the models there, the top model, we can click on the random forest. I then click on deploy. Now that I can deploy that model, I choose a model name that is going to be registered with the OML services components, the REST side. I choose the URI that I would like that model to be called. I give it a version number and I give it a namespace, and I say the model is shared. So now that model was deployed. The other option is actually, after you finished here, you can go to the models component. So our models listing shows you all the models that are built and the deployments that exist. So I can click on any of the models and I can deploy. So I'm deploying that decision tree now. And I can, again, the same thing. I can give it a name. I can give it the URI that I would like to see there. I will give it a version and a namespace, and I'll say the model is shared so other people can use it. And I say, okay. So now those models are going to be in the deployments. If I click on deployments, I can see all the deployments that are live right now on my server. And I see my two models on the top. So now for scoring that model, after I deploy them, this is what I will use. I'll access the Oracle Machine Learning services using my REST, right? On the left-hand side, I see the curl command to score a model that has already been deployed to OML services. On the right, I see an animation of the result. So basically, the idea here is that to score the models, you need to pass a valid token. Again, the same thing as before. But then with that token, you're going to access the URI/score, and then you're going to see the scoring results, right? In this case, I can put input records, and I can pass input records directly to a model like that. There are other cases where you will pass a select statement as well. That's for the Oracle Machine Learning for Python. So you will see different options, but we have all of these options available. So when you go now against that score engine, is that you're going to see that execution. And in here, I'm going to say top end details 5 on the right-hand side on the animation, because I want to see the top 5 most important elements to determine the classification, right? These probabilities that I was given back. So I see the weights of the attributes. And I can visualize those guys, and it can tell me, years of residence was the most important attribute on that customer, followed by Y box games and customer marital status. So those are the different things that I can see that affected that probability, right? Now that I've done that in AutoML UI, let's move on to serializing an OML model, right? Because OML services, as far as we have seen right now, we get a token and we can score a model, right? But how do I manually deploy a model to OML services without the AutoML UI, right? If you don't have the AutoML UI, you can serialize an Oracle machine learning model with PL/SQL and deploy to the OML services, right, in REST. So on the left-hand side, we have a procedure, right, an Oracle database procedure. So you'll run that PL/SQL code, and that procedure is going to create a special component called a write serialized model. And that procedure, then you can use it on a PL/SQL on the right, where the sysdba is going to need to grant you some privileges, right? So create or replace directory. So you got to create your own directory where you want to store those files. And you need to grant read and write to that directory, not write to the user that's going to run that PL/SQL. But then once you have that kind of authorization, you can run this code on the right, which actually writes out that serialized version of a model. In this case, the model is called GLM_mod. Is going to take that model and write it, and the output is going to be a file called GLM_mod.mod, right? So that is a process that can be done in any Oracle database today, or any modern Oracle database is going to have those kind of capabilities. And then but if you want to do that in a notebook and for autonomous database, specifically, so then we have created a notebook just to make it easy for people. So we're going to share with you guys this notebook in GitHub. And in here, basically the difference here is that in autonomous, you're going to need to have a few prerequisites, right? You're going to need to have a DBMS_cloud working for you and configured for the user. And you'll need a pre-authenticated request for object storage, which is where your models are going to be pushed to, right? So the first step is DBMS_cloud package. And there are lots of links and information on how you can work with them. And this is the script. So it's very simple. You just add a cloud credential, right? So you'll have to add a cloud credential for yourself there. Once we have that, we're creating just a data set. And then we are building two models, right? I'm building a regression model first, right? A GLM model. And then we're building a classification model next, right? So we're going to have two types of models there. So the classification model is next. And this is a decision tree in this case, right, that we're running. So now that we can check and verify that these models exist in the Oracle database, right, with that select statement, we can see that those models exist there. Now we can proceed with that same procedure we saw already before, the write serialized model. We have to find the autonomous database pump directory just to get the authorization to use that, because we are doing the write serialized model directly to that data pump directory, right? So you're going to need the authorization to write things to the data pump directory. And then we're writing both the GLM and classification models there. Now that pre-authenticated request comes back to help us here in DBMS Cloud, where you're saying, okay, this is where the location where I'm going to push the files, right? The GLM_mod.mod and class_mod.mod, right? Those two files that I created. So those two .mod files are now staged in your object storage. Now that I have a .mod file, what do I do with them? So in OML services, you can store models. So that's the first step. I'm going to be storing the models in there. I'm going to be calling the REST API using that curl command on the left. That's going to be exactly that. It's going to take that, you see the model data, that's the second to last there, that says, points to the file itself, right, which is the file that you have on your machine, and that you give it a model name, then the type, the model version, just like we said before. The model is shared, right? Things like that. When you do that, the result, as you can see on the animation on the right, the result that you're going to get back is actually a model ID. That's a unique model ID that you need to use for your model. So with that model ID that I have now, I go to the next step, which is create the REST endpoint. So I have stored a model. Now I need to create a REST endpoint for it. All I need for that is, again, a curl command on the left, the same thing. I got to pass my token. I pass the model ID, and now I also pass the URI. So the URI, what is the URI that I want to use so that the model can score then on now going live, right? Deploying the model. And then when you get back, the result is just saying, yes, this is your URI. So we're confirming that you have your URI and it was deployed on that date, right? And now the final step is the scoring, right? It's just as the one before, right? We have seen it again before, is you score a model deployed to OML services by passing the valid token, by passing that input. Remember that we already did that. The same is the same steps, exactly the same thing. We pass it a top N if we want, and then the input data sets, and we get back the scoring, right, of that model. So those are the steps. You get the .mod file, you store it in OML services, you create a REST endpoint for it, and then you can start scoring with it. Now, after that, what would happen if I wanted to deploy Onyx models, right? So Onyx are the Open Neural Networks Exchange type models. These are third-party models. Many types of third-party models can be added and created like this. And then you can convert them into the specialized Onyx format. And we can now publish those things to the Oracle machine learning services. So the first one that we're going to see is the classical Onyx model. So this is a classification or could be a regression model that we're getting. And this guy in particular was created by scikit-learn. So another person already had that model somewhere, converted that model to Onyx format. And now I'm deploying that to Oracle Machine Learning Services. The curl command on the left allows me to do exactly that. I give it a model name. I gave it the model Onyx Titanic. I give it a version, a model type Onyx, and the model is shared. And on the right, you can see, again, the same result as before. Any model that you store in OML services is going to give you back a model ID, right? So the same thing can be done using Onyx image classification models. So now I have an Onyx model coming from Efficient Light 4. That is a classification model for images, but it's the same thing again. I can pick up that and I can creating that curl on the left-hand side. You can see I gave it the model a name again, a version, model type. Now it's different. It's Onyx underscore IMG for image. And then I have the model data and I pass on that zip file for that. So those are the two types of things I am storing as a first step. As we saw before, the next step is creating the REST endpoint. So I create the REST endpoint to call that model. And then I now can see and review that passing the model ID, I can get the URI, right? Just like before. So the same thing is going to happen with my Onyx image model, right? Where I will have the same exact process. I have now the same component. I pass the model ID and I get back, and I pass the URI and I get the OK, right, from the environment. So when I then deploy my model scoring, that's the final step, right? The machine learning model, right? That is now the one that is a classification model on the Titanic data set. I am passing the data, and you see the way that I'm passing the data as raw data as an input records, right? So when I pass it on the right, you can see the scoring, right? The result. So I get back the result, the different labels, and the probability, right? So I got the probability of 0 and the probability of 1 for that particular person that I submitted, right, as an input records there on the left. So that is for the normal classification. But if you think about images, then I can also pass an image, right? So if I have an Onyx image classification model, I need an image. So I'm passing that shark that you saw on the right is a tiger shark. I'm passing that as a parameter. So on the left, you see the code. I have that parameter, tigershark.jpg. And on the right, I see the result. Now, this model has 999 different types of things. And thankfully, I see that the tiger shark got a 0.9999 probability, so very high probability. So it is an expected tiger shark from the model. So that's basically the process for deploying all of these models, right? At the end of the day, when you have all of these processes going, there are many potential hazards that can happen and can get in your way of deploying a model successfully. Most of the time, the models are developed on languages that are different than the environment that you're going to deploy. So the companies have production systems, transactional systems that need to work with these models, and these models might be too complex. It might be neural networks that is too long or too large. And those things take time, and you have SLAs that you have to abide to, right? So you can't just risk your scoring taking 10 minutes, right? So there are several things that you have to pay attention to. So whenever inference is needed, what happens is Oracle Machine Learning, as I showed you today, helps with that by unifying all of these abilities, right, of SQL, of Python, and open source Onyx models as well to work on that same environment, right? The second thing is that the models require normally the data to travel, right? So if you have a scoring engine running alongside your main database or data warehouse, and you have to take the data out of there, then there's always a risk, right? Security risk of pulling that data out and then sending that data, shipping it to a different server to get scored and then get back into your data warehouse, right? So the Oracle Machine Learning definitely helps with all of that process because the data mostly never leaves the Oracle database, and then the environment is always tied up and all secured under the same, same components, right? So we use all the same technology and security and everywhere. And scalability is also key. So we have done extreme testing with all of our models. We have models working on billions of records. So there's not a problem with scalability on the Oracle Machine Learning. But we have seen that many processes sometimes have. So if you try to score models, right, with a one-to-one or one-by-one, or you have to instantiate a session before running that scoring, that takes a lot of time and it can be problematic. So we have both in batch in a large scale using the Oracle Machine Learning database, and we have a very fast millisecond scoring with Oracle Machine Learning Services REST interfaces. So we have, we can help with both kind of capabilities. And also the integration with end user applications is critical, right? So it doesn't matter if your model is beautiful and you can do it work well if it's not open to end user applications in a very easy way, right? So the application developers really want to have as simple as possible, right? Give me a REST or a JDBC connection or ODBC connection that they can call models very easily with, right? They can't be fussing around with too many scripts and complex things. So that's something else also that Oracle provides in the solutions. So how do you get a model, right? Then basically it's definitely easy. There are many alternatives and options, and what Oracle Machine Learning provides is a wide range of capabilities. So you can take basically SQL, as we've seen today. We can take Python. So you can take not only the Oracle Machine Learning for Python models that run in database, but you can also use scikit-learn, and you can use definitely all the open source algorithms, right? And also you can use R as well. So we have capabilities for Oracle database that will run R as well, R engines in there that you can use. And we can tackle also any third-party machine learning classification models and regression model that can be converted to Onyx. And that's important. There's a wide range of tools from many, many vendors that can do that. So we can actually just take those models and use them to score. In addition to that, I showed you guys the third-party image classification models as well that can be converted to Onyx format and can be used. So basically, in conclusion, what we've seen today is the model deployment with Oracle Machine Learning. We saw several ways of putting the models in production, from native Oracle Machine Learning in database models registered immediately when you create them in SQL, and they can be scored by SQL or even Python, right, with OML for Pi immediately. We saw that models can be exported as well, via data pumps to serialized formats, and we can take those serialized models and then register them. And also we saw open source Python models being created and using open source machine learning packages like scikit-learn, right, and transferred to the Oracle Machine Learning Engine so that they can be scored via Python itself or via REST and SQL as well. And finally, we saw the Onyx formatted machine learning and cognitive models for classification and regression that can be also registered with Oracle Machine Learning Services and put into production and as REST endpoints. So any Oracle cloud data center can host those models for you. So with that, I would like to thank you guys, and I'd like to open up for Q&A. So let me check here the questions that are coming in. So one of the questions I see is, can I use a TensorFlow model that does image classification with Oracle Machine Learning? Yes, you can. So the idea is you can build models using your TensorFlow and then convert those models to Onyx format. There are a few converters in different releases of TensorFlow that you can use. And then you can put them to use with Oracle Machine Learning Services. So we can do the scoring part of that using OML services. And you can use our REST APIs and just pass a new image like I did with the Tiger Shark, for example. You can pass a plain image, but we can also support passing tensors. So if you have that capability on an application, for example, we can also receive tensors and then give you back the results for that classification. Okay, yes. Another question, can I use any Python package with Oracle Machine Learning? So on Autonomous Database with the Oracle Machine Learning for Python 1.0, users have access to a select set of packages pre-installed. That includes scikit-learn, as I showed you guys, and matplotlib, and a few others, NumPy and SciPy. We'll expand that list in subsequent releases. We're already looking at what our users are been asking for. So we're adding to that list of packages. And if you have it on premises, then the release on premise, you can install whatever, because you can use whatever release of Python packages you would want to use there. The other question I see here, what if I already have a model that I like to use built using a third-party Python package? Can I use Oracle Machine Learning to deploy that model? Yeah, so what we saw before as well, in Autonomous Database, you can do that by converting your custom Python model into Onyx. So as long as that's a classification or a regression model, you can convert that into an Onyx format. There are specific Onyx Python packages that you can check, and they can convert those models into Onyx format. And with the Onyx format, you can deploy them in Oracle Machine Learning Services, just like I showed you guys before as well. I think that's it for today. That's all we have time for. But Before I go away, I would like you guys to please take a look at oracle.com/machine-learning. There you're going to have a lot of information about Oracle Machine Learning, all the different components we have, and then tutorials, live demos, and all of the nice things. And also we have GitHub. So in the GitHub, in the original and Oracle Git, there's something called the Oracle-DB-examples. And in that, we have a folder called machine-learning. And if you then clone that repository, you're going to find a lot of demos. There are notebooks, data sets that we use, ODMer, Python, R, SQL. You have all of the different components there that you can make use of. Okay. That concludes the session today. Thank you very much.